And we're live. Thank you very much for joining us. And sorry for the slight delay in getting started. I had to have a disagreement with my laptop, but it seems to be working fine now. And okay, so this week we're going to talk about the wonderful topic of functional composition. And there might be a few big words in this in this session today, but I'll explain everything through code and try and make it as nice and simple as possible. And we will explore things like the comp function. We might take a little look at the Juxt function as well, and yeah, see how everything is going in that way. But yeah, we're going to start with the basics. We're going to build up to functional composition by showing you all the bits and pieces that are required to understand it as well. So I'm going to share my screen. Let's see. We present to everybody. Wow, psychedelic. There we go. And I did have some web pages up there, but I seem to have lost them because my computer decided to reboot. I didn't want that, did I? No. Let's see. That one. Let's hide that. There we go. So if we go and look at Clojure functional composition, that's to make sure there's no questions. There's no questions there. Okay, cool. So there is, where is it? It was that one, I think. Yeah, there we go. And let's make that a little bit bigger. Boom, boom. So this is kind of an example of composing functions. It's quite simple. There is some mathematical kind of equivalence of this. It doesn't really matter too much if you don't understand the maths, but yeah, you can add to it if you do understand a little bit of, I guess this is fairly basic kind of algebraic maths. So it's hopefully you should be able to understand that. But essentially here we're defining a function called third, and it's essentially a composition of several functions all working together. So this is quite a normal approach for Clojure and for Lisp. You would have a function. So this function here called rest takes the argument x, which we pulled in for the argument. So when we call third, we're giving it this list of keywords. List of keywords that are representing fruit. And so this argument is pulled in by this x. So this x value, this x name gets this value, and so we're essentially putting the list of fruit in here. Then we're calling rest on that data. So if you remember your rest function, it basically is going to return everything but the first one. So we ignore the first one, which is orange, and then we return the rest of those. So it would be guava, apple, pear. And then the result of this is then passed to this next function, which is also rest. So that would do the same thing. So we would drop guava, and then we would just have apple and pear. And then that result of this here is then passed to first as an argument. And it gets the first element, which in this case is apple, and we see the result here there as well. So this is kind of fairly normal. We're using functions or the results of functions as arguments to other functions as well. Ooh, it's getting windy outside. And so we can do that. So we can kind of go as deeply nested as possible as we want to. But there's another way that we'll look at it, something called comp, which allows us to kind of basically create, basically do comp first rest here as well. So it makes it a simpler way to actually express what we're trying to do without all the without so many brackets actually. So a lot of people in Clojure get, when they look at it initially, say there's lots and lots of brackets. Which is defining the structure, but there are more elegant ways to kind of do it by using this comp function. Again, it's a higher level of abstraction, so you can just basically give comp the functions you want to compose together, and it will do all the work for you. So we're going to explain how that all works in detail. And yeah, there is some explanation here. I'll put the link to this page on there as well. But yeah, especially if you like a little bit of maths, but you don't need to understand maths at all. So basically, we're just in terms of maths, we're just taking this function and its equivalent to this function as well. So let's actually understand that a little bit more detail by going through some code examples. So let's switch to Emacs. Any questions so far? Hello, Simon. I probably pronounced that wrong, sorry. Let's make my code a little bit bigger. Make it bigger. So I'm using Spacemacs as usual. There are some videos on how to use Spacemacs for Clojure development in my channel, which I'll also link at the end of this video. So let's go right back to some basics of functions and Clojure. And feel free to ask any questions as we go along in the chat, and I'll try and keep an eye on them. So a function, we've got a function here called str, short for string, and it's basically going to join its arguments together to form one string. And it's going to return let's write for my REPL. It's going to return a value. In this case, the value is going to be a string. Println is going to do the same thing, although println is it's an interesting function because it has a side effect. Oops, let's do that. There we go. So if I call string and get it to print the result underneath. So this results, the result it's returning is this string, join two strings together and more. If I do println, then it's actually going to print the string. It's going to join the arguments together to form a string, but this time it's going to print the string out into the REPL. Or if I was running this as a command line app, then it would be printing out to the command line. But it still returns a value. Even though it's got this side effect of printing to the REPL. Let me just show you that. Boom, boom. You can see it's just showed, it's got the REPL, it's printed out the string to the REPL here. But it also returns a value as well. So every function in Clojure is going to return a value. In this case, the value is nil. Even when a function returns nil, it's still a valid value. And for comment as well, you can put things into a comment if you don't want. If you load this, if I loaded the namespace in, I wouldn't necessarily want all of the code to run. So I can put some of the code in this comment function. But I can run the actual function itself. Oops, sorry. I can run the function itself and get the value of that. But if I evaluate the function, the outer function, the comment function itself, then I'm going to just get nil. But it's still returning a value. So whenever I call a function, I'm always going to get a value, which is important when we actually come and look at functions as arguments. So you're used to, here we're giving specific values as arguments here. So here we got string, we got a number, another string, and so on, so on. So we're giving very specific values as arguments to our functions. And we can all, because a function, when you evaluate it, gives a result, gives a value, then we can also use a function as an argument as well. So here we've got a very simple function I've defined. So I'm using the defen, so I can call it explicitly by name. And this is going to take an argument. And I could call this with just the results of, I could call this with just a simple value, display, oh, I haven't evaluated this, have I? Oops. Because I restarted. There we go. Let's evaluate that. Oh, oops. No, evaluated the wrong bit of it. Oops. Let's try again. Boom, boom, boom. There we go. So that's evaluated. So now my REPL knows that that's what that function does. And so we can display results. There it is. And we could just give it a number, specific number, and that would work. Boom. Put this 42. Although we can also give it a function. So this star is the multiply function. So we're giving it a function as an argument instead of a specific value like we did here. And this will work because this function is evaluated, and then that results is a value which we can then use with the display results function itself. So if we evaluate this, boom, 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 then we get our results and everything works. And so we can call functions, we can call functions with values. Because a function returns a value, we can call a function with a function as an argument. Hopefully that's fairly straightforward. And the more interesting thing, the thing that took me a little bit of time to get my head around things, was a function that instead of returning a value, so all these functions here have returned values, in this case just a string, we can also get a function that returns a function. And because a function is, when that evaluates, that would be a value. So we're still following the same kind of pattern, but it's a little bit of a step above. Like, instead of just returning a simple value, we're now returning a function that we can then use. And this is quite useful. Sometimes we want to do some. We want to build up a function before we use it with an argument, and then we just return that new function that we want, and then it can work with the argument. So we might not have quite the function that we want to have, so we kind of build up something, and then the result of that, we kind of build up this generic function and pass it to this new argument, and we get results. And there's quite a few. We'll cover some foreclosure ones in a minute where we see that we're actually doing that exact kind of thing. We're returning a function instead of returning a value. So let's have a look at the example. So we've got here defining another function that returns a value. So this is just returning a value, as we've seen before. And this function is actually returning another function. So here we're just using the function, the inline lambda function argument. We can't use defen here. That wouldn't make any sense, because this function is supposed to be used inline. It's supposed to be a lambda function. So we're just going to return that. And we can then use that with some kind of argument. So if we've got, I didn't evaluate this, let's evaluate that function. And so when we call this, it's going to, so we can do a function that returns a function, and we can give it an argument, which is, I don't know, 21. Actually, no, we want to, let's see, function that returns a function. Let's do something simple called inc. And so this would then return, this would return something like, it's like function arg, actually, yeah. Where we go? What we just do? Let's evaluate that. I did evaluate that one. There we go. Boom, boom. This is returning a function, so you can see that it's not returning a value, it's actually returning this function, and it's because it's an inline function, it's giving it a particular internal name. So this fn-13627, that's the actual local name of this function that we've just defined. So we're not actually getting a value here. We're just actually defining, we're just getting a function definition. So we would actually need to call this function that we've just used inline to actually make any sense out of this. So if we copy that, and so to call a function, we need to put it into a list. So it's still like calling inc or star or something. We're still doing the same thing, except we're just putting our function definition in here. and then we need to, because this function is going to take an argument here, then we need to pass an argument to this function, otherwise we get an error. So let's do that. Because we're using the inc function, which is going to work on a number, let's give it a number of 41. So that argument will work with this function. If we give it a string, then it would give us an error. So now if we evaluate this, we should get our results. 42. There we go. Any questions? Any questions? No questions. Hang on a second. I did get a drink of water. Oh, there it is. Oh. And so you can go and define functions. So we could have here this function could also return a function, which also return another function, and you could have functions all the way down. At some point that will get quite confusing. But in this case, it's quite useful. Well, this is a very simple case because we're not really benefiting much from this, but the more interesting our function that we return is, the more valuable it is to take this approach. So we'll see that when we go into the comp function as well. No. And so the last kind of piece of the puzzle before we get to comp is kind of polymorphic functions. But actually, before we do that, I'm going to jump to see some of these things in action. I'm going to jump to some of the foreclosure solutions. So let's space. Let's go to my foreclosure setup. And we want to go to, it was 19 last element. I always think of the Terry Pratchett book, The Last Elephant, when I think of this problem. So this is a foreclosure, foreclosure.com exercise. So which one I've done before. Let's see, going here. See if we go to foreclosure, and this is problem 19. And you can see, so that this is, you want to write a function that returns the last element in a sequence, but it's not allowing us to use the last function that would actually help us just solve this problem. Oh, you can use comp. There we go. We'll come to that in a second. But there's so what I've done is redone this exercise a little bit from the previous video. So we've still got this approach where we could just loop through the collection. So we've got our collection that we need to find the last value of. We're going through the collection to see if the count is equal to 1. If the count is equal to 1, then we return the first value from that collection. So we go through, and then if it's not, if the count of the collection is not equal to 1, then we'll just recur. We'll just pass the rest of collection round and round. So you can see that in action if I start the REPL up for this namespace. If I do a little bit of debugging, you can kind of see it going through each iteration. But essentially, it's quite a low-level approach. Oops. But it kind of shows you the most basic way of doing something. But we can abstract over this to make it a lot more nicer to do in Clojure. So if we debug buffer, there we go. So we've got a collection, and it's the size is 5. So this is going to be false. So we're going to recur, and we're going to pass 2, 3, 4, 5 around. the loop. So the collection is now 2, 3, 4, 5. So the size is 4, false, so on and so on and so on. And you keep going around until the collection, until the if statement is true. So there's one thing left in the collection which does equal 1. So that is true. So we get the first value of that collection, which is 5, and we return it. So that's very low level step. It's very prescriptive way to do things, and we can use functions together to get a nicer, a less kind of prescriptive way to do things. So we can reverse the collection, and then the collection is just 4, 5, 3, 2, 1. So then we can just get the first value of that. So it's much simpler than having to write our own loop recur, and it's a lot less code for us to maintain as well. And anybody who's done a little bit of Clojure should easily be able to understand that. And then for the foreclosure stuff, we just put that into a function or a short form of function, of the function. But we can actually also use this as the comp. And so we can actually, if I just show you the answer here, so we can actually just do comp first and rest. And yes, Simon. Yeah, it's a bit like callbacks, but a lot simpler in that respect. Yeah, so it's essentially, so comp is going to join, is going to explicitly kind of give the argument to rest to the rightmost function, and then the result of that is going to be passed to the function to its left. And then once there's no functions left, it just returns the result of evaluating that last function. So that's how it would work for this. So rather than doing, rather than doing this first reverse or first function, we can just do comp first and reverse. So it makes the code a little bit simpler to read. And once you're familiar with functional composition, then it is a lot quicker to actually read through the intent of the code itself. No, it's not WordPress. I might not have tested this properly. Oh, yes, yes, oops. No, she didn't test that very well. Thanks for spotting my bugs. May have been late when I was writing that. I did stay up until like 2 o'clock one night to do some of these. Thanks for my bug. There we go. And so let's just go back to here. So we've got, so one thing we kind of need to look at just before we look at comp in a bit more detail is this idea of polymorphic functions. And so if you haven't come across that, so if you're using Java or other kind of languages like that, you get polymorphic behavior based on types. In Clojure, because it's dynamically typed, we can have polymorphic behavior based on the number of arguments that we give to a function, rather than the types. Although if you use def methods and def protocols and stuff, you could also dispatch on type as well. But essentially, if we've got a function in here, we've just got one. I guess we've just got one argument, which could be a collection. It could just be a single value, but we've only got one of them. So when we call name, we can only give it one argument. We can't give it 2 arguments, otherwise it would fail. We can give it a list of 1 and 2 if we wanted to, but we can't give it 2 vectors. That would also make it fail. So we can only give it 1 argument specifically. So we might have a function that's the same thing, but is actually kind of, we want to have the option to have 2 different ways to call it. And so rather than defining it twice, rather than defining two versions of a function, we can define a single version of a function with a single name and give it two options of what to do based on how many arguments we give it. So in this case, we're not giving IamPoly any arguments, and so it will run this behavior. So it'll evaluate this piece of code and then give the result. Whereas if we gave it a single argument, then it would evaluate this piece of code instead. And so if we call this, so if we call IamPoly, then we get just a default message. So we just get this expression. So it prints out my name is Polly. If we give it a specific message, then it's going to return that message that we're giving it. And you notice that actually for the option where I don't provide an argument, I'm actually calling the function again, but with a default argument. So it will actually this piece of code will actually then go back to IamPoly and actually call this piece of code. But you don't have to do that. You could just return I could just return the string or some kind of other behavior. Well, that didn't work. There we go. But, yeah. So I could just return the string there, and it would just So you can either have it defensively by getting it to call itself again with some defaults, or you can give it a completely different behavior, however you want to. But you can basically have one function that will respond differently based on the number of arguments that you actually give it. And you could also have one where you got an infinite number of arguments as well. So we can do, and so it's the only real difference in syntax is that we're putting each of these separate lines of code into a list. So that based on the number of arguments, then we're going to run one of these run one of these lists of code. So we can do we use the ampersand, say just args. So if there's any number of arguments, so if there's two or more arguments, then we would then do this piece of code here. Oops. So that's useful to understand for comp as well, because comp returns a polymorphic function when we use it. So it's okay. So any questions about functions? So we've covered functions, return values, and functions can take a function as an argument because it's going to return a value when we when we evaluate that function, and functions can return functions because they're a value, or they will evaluate to a value. And we can also have a function that defines can be defined polymorphically, so it will respond differently to depending on how many arguments that you actually give it. So those are the only things we kind of need to know, I guess, for comp, to understand comp, how that works. So let's have a look at that. Comp in action. So here's a simple, and again, it's quite a simple example. I probably wouldn't do this in production, but just to kind of help you get into this. So comp is applying the functions from right to left. So again, mathematically, we're going to apply a function to a value, and then the result of that is going to be a value that this function is going to apply, use to get the result, and that is equal to a function that is working on that as well. So a little bit of maths for you there on the Saturday morning. So let's look at an example. So here we're just defining trim in uppercase. And we don't need to use a function here because we're actually just defining a name for a for an expression that we're going to use, and we're going to use that with any number of functions that we want later on. And so we're using comp. So comp is short for compose. So it's basically going to compose functions together, just like you would compose an orchestra, except this is sequential composition, whereas an orchestra is all happening all at once. And so we're going to compose the upper class function from closure string and the trim from closure string as well. So we've got a couple of functions here, and so we've defined a name for this expression, and then we're calling it with a specific answer, a specific argument. So we're just calling it with one argument here, which is a string. It's got a couple of spaces in there, and it's all lowercase. So first of all, so this argument is going to be passed to string. Sorry, this argument is going to be passed to trim. So we would trim it first, and then the result of trimming it would then go into uppercase, and we get the result. Time's going off. There we go. And so what does that actually look like in a little bit more detail? So it's the same as writing comp. We're going to call comp. We're going to call, so we're composing uppercase and trim together, and we're giving it a specific argument called don't panic. So I'll just make that a little bit more obvious. There you go. So this is the comp expression that we're calling, and we're going to give it a single argument. And so each of our functions are going to take this argument, or this is going to be passed to the trim, and then the result of that is going to be a single value, which is then passed to uppercase. So we get don't panic. Let's have a look. Again, this is a very simplified version of how comp works. We'll go into a little bit more detail in a moment, but let's have a look at the simplified version of this. So comp is a function in Clojure core, so we can use it any way we want to. It's going to take like 0 or more arguments. So you can pass as many functions. You can compose as many functions together as you want to. Obviously, the more functions you're composing together, the more complex something is. So if you're composing like 50 functions together, that's probably too many. And you can probably deconstruct your algorithm a little bit into separate functions to make it a little bit easier to read. But in theory, there's no kind of upper limit to how many functions you can compose together, but keep in mind the readability of your code as well. So here we've defined a couple of functions just to make it a little bit easier to type into comp. I've put 3 P's in there on purpose so it doesn't clash with an existing function. So we've got uppercase and trim string, which are just basically which are just basically placeholders for calling closure string, uppercase, and trim. And so this is how we would compose our functions together. We just do comp, uppercase, trim string, and the comp function. We return something more complex than this, but let's just take the specific happy path to make it simple. So it's going to return a function that's going to take some arguments. In this case, it's going to take, let's say it's going to take an argument, and it's going to pass that argument to trim string, and then the result of that is going to be passed to uppercase. So if we call this, if we put this function, we put this function that comp is returning, we call it with an argument, then we're going to get the same result. Let me just reevaluate that just to show you I'm not making that up. I'm making that up. Oh, I changed that. I didn't change that. There we go. Always good to retest your code when you change something. Oh, I've broken it. Oh, okay. I didn't evaluate these, did I? No, there we go. Oopsie. There we go. Now, he says. Always good advice. So yeah, so I'm calling this function because it's in a list. It's calling this function, and it's going to run trim first and then uppercase and give me the result back. So that's kind of the simplified version of the function. And let's look at comp in a little bit more detail, because it does return something a little bit more interesting than just that, the way we've described it initially. So let's assume we're still passing two functions into comp, and then so comp, well, so if we've got a function of f and g, then if we do comp f and g, it's actually going to return this function, which is a lot more interesting than the example we initially gave, which was kind of just a cut down version of what comp actually does return. So we can see we've got a function that's returning, and it's a polymorphic function because there's 1, 2, 3, 4, 5 different ways for this to be called, for this to evaluate based on how many arguments we actually give to this function that's returning. So here, when we're returning this function, we're giving this function here a specific argument. So then this would, in this case, if we're just giving it one argument, it would call this line of code. If we were giving it more arguments, if we were giving it 2 arguments, then it would call this line of code. Oops. And so on and so on. And if we gave it more than 3 arguments, then it would obviously call the last line of code here, which again has a slightly different thing, which is going to apply these functions over the arguments as well, because there's a lot of more stuff to go there as well. So essentially, if we don't give it any arguments, it's just going to call G without an argument, and then return that result to F. With 1 argument, it's going to call G on the arguments, and then return that result to F. 2 arguments, it'll call G with X and Y. So you do need to make sure that your functions, F and G, whatever they are going to take the right number of arguments if you're going to compose them together. So ideally, they would take like a multiple number of arguments, so they would be polymorphic themselves, and so on and so on. So that's a bit abstract. So let's have a look at a specific case. So if we're using the functions we previously defined earlier, are purposely misspelled uppercase and trim string, then the function that we would get back from calling this comp function with these 2 functions, it would look like this. So we'd get this kind of function back that we would then call with whatever arguments we had on the end of the comp function. So here we've got uppercase, trim string, uppercase, trim string, so on and so on and so on. So hopefully that's a little bit easier to kind of see a specific example there. And then, and so then this function that comp has returned, if we put this into a list, we can call it, and we're giving it a specific argument here. So this is going to come along and evaluate this and say, oh, I've got 1 argument, so I'll do this line of code, and so it'll trim string, and that all works just as normal. So we get our results as we've got many times before. If we call this with 2 arguments, here we're calling it with 2 arguments, then this does call this line of code. And then we find out that actually trim string only takes a single argument. So that's a bit of an interesting challenge. So if I evaluate this, I should get an error saying, yeah, wrong number of arguments 2 passed to trim string. So therefore, I've got some limitations on what I can compose if the trim string does not accept multiple arguments. If we kind of went to we went to trim string and yeah, so that's only taken one argument. Yeah, so we'd have to implement our own trim string that actually accepted multiple arguments. So trim, so we'd need to maybe map trim over the arguments, and that way each of those would be trimmed. Oops, gone too far. So yeah, so just a note to be aware of, like if you're going to compose functions, then if you're going to do it with comp, then they are going to expect kind of multiple different numbers of arguments as well. So you need to kind of typically you would define them so that the function you call, it would be, if it's a defin, then it would either take multiple arguments. So plausible function. So it would either take multiple arguments, and you can do that with the ampersand, and then whatever name you want to use for the arguments. It doesn't have to be arg, it can be anything you want to. So hopefully something meaningful. Or you can create like a polymorphic function, as we've done previously as well in some of the previous examples. So those are the kind of two options to make your functions composable. Like most of the, there's a good percentage of the functions in Clojure core you can use with comp as well. But if you do find an issue, then it's probably because the function you're trying to compose together with comp doesn't take the right amount of arguments that you're trying to pass to it. Any questions? Nope. Okay, what else we got? So let's go through, let's just jump back to Foreclosure. So here we got here where, oops, let's not scroll too much because it's distracting. So we got this number 19 foreclosure challenge, where it's basically saying we want the last value, but we can't use last. And so if we use comp in this case, we can do comp first reverse, and comp is going to return a function that looks like this. And so reverse, and so because we're passing it a single argument, because we're passing a collection, then it would reverse the collection and then get the first value from that collection. And like I said here, and then it would give us the result of 5. So this is working exactly the same as reverse and first. It's just the way that we're expressing how they work together is slightly more abstract, slightly more simplified in terms of the syntax, and a little bit more abstract. So we can either do comp first reverse, we can solve it with our own arguments, our own function definition, or the short form of that as well, or we can do the loop, as it were, as well. So obviously this is more idiomatic closure. So if your functions compose well together, then comp is a nice option to choose to solve this problem. If your functions don't compose together very nicely, and you can't change them so they do, then defining your own function, then you can also control like the number of arguments that it's going to take and what to do with the different arguments as well. And that's just a short form of the function definition. Cool. I think there's another example in 20. So 20 is quite similar to the challenge 19. So here we want the second to last element, but there's no restriction in functions we can use, but there just isn't a function that returns the second to last. There's no function that will return for or b. We've got first, second. The second would work for this one, but it's not actually, because it's second and second to last. But in this case, second is 2 and second to last is 4, so we couldn't use second. We could use rest and get the first one, but sorry, you use reverse and get the second, which is the approach we've taken. So we've got, we reverse the collection and then just get the second one. Again, we could define this as a function for foreclosure. There's also an nth approach we can take, but then we can also do comp second reverse as well. So that's another way to solve that problem. And I think same for 21 element. Yeah, so for the nth element, we're going to use first and drop together. And it's the same as having a function first and drop as well. So drop's quite interesting because we have to change the order of the arguments that we pass to drop. Drop takes the number of elements you want to drop from a collection, and then it takes the collection of the arguments. So we have to kind of swap them around, which you can see in here. So in the function, we're doing collection number as the arguments, but drop wants number collection. So we have to kind of put a little anonymous function around the drop function, just so we can swap over the order of the arguments going into drop. Cool. So that's some hints on how to solve those if you haven't looked at those foreclosure ones already. All that code is in, I think it's been pushed to my foreclosure. Let's have a look. I might not have pushed it yet. So on GitHub and my JRockets account, there is far too many repositories. But if you go and look for foreclosure, and there's a whole bunch of solutions in there as well. Oh yes, I've got 21, 20. I've got quite a lot of ones in there, and they're not just the answers. I'm explaining how I've got to the answers and the different ways, the different approaches I've taken as well. So it's so I do suggest you, if you're going to look at this, try and do the foreclosure exercise yourself first. And if you get really stuck, or if you've done the answer and you want to kind of see some alternatives, then take a look at my foreclosure thing for more of a discourse in how to solve these problems. Because a lot of them, if there's, I've done a loop recur version, I've done a recursive function, and tried to see how more high level abstraction I can apply to make them kind of simpler solutions, or simpler to read solutions, using Clojure, using some of the more abstract functions in Clojure as well. Let's see. What else was I going to say? Oh yes, let's switch back to tab. Okay, so there's probably quite a few nice approaches, and once you get a hang of comp, then it is quite useful for not just simplifying your code, but also thinking and encouraging you to think about composing functions together and using functions with other functions, because it does, I mean, that is kind of like the recommended approach for Clojure, is to have simpler functions that work together. So each function does a specific job and or a specific transformation of data, and or transforms data in a specific way, and then you just compose all those functions together. And each function is quite simple to understand and quite deterministic as well, because we're giving it immutable data, so it's not going to change. And so you can just look at a function and say, okay, well, given this data, this is the kind of result I'm going to expect. So it makes your code a lot easier to understand. And you're building the ability to do more complex things by using very simple building blocks of using simple functions that you compose together. And if you can do that, then you're going to create some very nice Clojure applications and services. Okay, let's go back to my thing there. Anything else I want to mention? There is also Juxt as well. Juxt is also a similar kind of thing to compose, but it's allows you to do other interesting things. I think the difference between Juxt, I should remember this actually. Let's go back and look at the Clojure Juxt. I think because of the name, it actually is the juxtapose version, so it's changing the order in which you're doing things. So here we're doing Juxt A, B. Okay, right. So we're going to get, so comp is kind of would pass the values to B, it would use B first. So here we're using the keyword as a function to pull out 2, and then we would pass that to A, and we would get 1. But Juxt here is kind of basic saying I'm going to apply the function A. So A is like a get. It's like get me the value of the key A, and it's going to return that value, and then we're going to call Juxt with this argument again, and this time it says get me the value that B points to, which is going to be 2, and so we're getting the answer there. So we're juxtaposing those functions together to actually get some values, and then it just joins the results together at the end. So it's another interesting thing. Once you get your head around comp, then looking at Juxt is quite an interesting function to look at as well. I think we'll cover that in a bit more detail in another example. Let's see. So this is taking 3 from here. So this, so this is an interesting one. I think make that a little bit bigger. So we can see if you're on a small screen. Oops, too big. So here we're calling Juxt with take and drop. So take's going to take the first number of elements. So we're going to pass it 3. So take is going to take 2 arguments. So take is going to take the number of elements to get from a collection and the collection itself. So take is going to get 3. It's going to get the first 3, which is 1, 2, 3. And drop is going to get drop the first 3, and we're going to get 4, 5, 6, and then Juxt is just going to return both those values in a suitable collection here. So Juxt is kind of doing similar kind of thing, except it's in a different order to comp as well. So if comp doesn't quite work, then Juxt might be something that you actually find more useful, because it's got slightly different additional semantics on top of it. Cool, but yeah, Juxt is quite a nice language, and there's also I do believe there's a little consultancy company called Juxt in the UK that are very into Clojure. Okay, we're about coming up to time, so I think that's all I was going to cover in functional composition. I don't think there's anything else I wanted to mention. Let me just double check. If anybody's got any questions, then now would be a good time to ask them. But I hope this has been useful, and I hope you found this quite eye-opening. And yeah, again, it is just another way to help you thinking about composing functions together. And when you can do that, then you are thinking a lot more idiomatically, a lot more in how we do functions, in how we do the design of Clojure, the design of our Clojure applications. Okay, there doesn't seem to be any more questions. I'm going to leave it there. And thank you very much for listening. And I hope you've enjoyed that. If you have any specific ideas for other topics you want me to include, then please let me know, either in Slack or in the meetup page comments. And I will see you again next week. Thank you very much for listening. Thank you. Bye. Whee.